Hi, I want to give an explanation to essential question number 3, version 5 in the fall of 2011. So this is our usual setup here. We've got our assets all lined up. Here's what the payoffs and costs are in each one of them. Here's the present worth calculated, internal rate of return calculated except for asset A, and then those incremental internal rates of return that are lined up right here, as well as the lives of the assets, just in case it falls into this little gap, you can tell how long they last. So let's start with question number 1, which is usually fairly easy. So all we're doing here is asking you to calculate what the present worth is. Sorry, not the present worth, the internal rate of return. Remember, this is one of those simple cases. So what you're doing is you're taking that payoff that you have in the last time period, which is 29, putting on top of your cost in period 0, which is 9, and then you're taking the one on the life root. So you go ahead and go 1 on n, you subtract 1, and that should give you what the internal rate of return of asset A is. In this case, I think it comes out to be 33.68%. The key thing is that for a later question that this is bigger than 20, and that's the important part for us a little bit later on. Now, moving on to the second question, this is the one that is concerned about years of service. So the question set up so that you provide 12 years of service, which means, for example, you buy one of asset A up here, you let it burn out in year 4, you get another one, you let it burn out, get another one in year 8, and then you get another one in year 12. So the idea is you're supposed to be attacking this with annual worth. Now the annual worth calculation is actually not all that bad, because what you're doing is just taking your calculated present worth. So I'll go ahead and grab the one for asset D real fast. And its present worth is 9.56. And then what you're going to do is you're going to calculate A, given that you know P, because you already know the present worth. The interest rate is what you're using already, so that's 10%. And N is supposed to be the life of the asset. Asset D lasts 3 years, so you put in a 3 right there. And that should be the, what the benefits are, or the costs are each time period. And I think this one works out to 3.84, but we'll check on the second page in just a bit. Question number 3 is probably one of the easiest ones. This says at a minimum acceptable rate of return of 10%, which means you can use these calculations right up here, and no service requirement, choose which asset's best and explain why. The why is that, well, hey, I can use the present worth exclusive choice criteria, and all you got to do then is pick the one with the largest present worth, and that's asset A. So if you write down something like A has the largest present worth, you should be A-OK on this one. Now the last one on this particular example is tricky. And what's going on here is it says that at a minimum acceptable rate of return of 20 and no service requirement, which asset would you choose? What I'm doing is I'm forcing you into using the incremental internal rate of return criteria. Now why this one gets tricky, why there's actually going to be 2 answers for this one given the procedure, is you have to order these from smallest initial investment to largest, which means it should go A and then either B or C, depends on, and then the last one is supposed to be D. And these incremental internal rates of return are to a certain extent fake, because when we calculate the internal rates of return of these assets here, we can end up with 2 roots. That's just one of the roots that sits right there. And so it's because only one of the roots there and not both of the roots are there, we end up with a little itty-bitty problem. So let's start off with making sure we knock out all the assets that have internal rates of return less than 20, and that ends up being none of them, because the internal rate of return of A is 33.68. We're covered. So let's start to see, and here's the first pass. We'll first try to see what happens if we go from A to B. If we go to A to B, it turns out that 84% is greater than 20, so it looks like the upgrade's a good idea, so we go from A to B. And now what we'll do is we'll consider C to be larger than B, and so we'll look to see that B to C upgrade. So we go over and we see that B to C gives us a positive infinity payoff. And so we say, oh, that's a really good payoff, and so we upgrade from B to C, throwing away B. And then what we do is we check to see if we should upgrade from C to D, and we check that incremental internal rate of return and find that it's 28.92%, and we upgrade to asset D. So D ends up being the answer. So let's try it the other way. Remember, this is just because this is an unusual example. And consider to have A be the first asset, then C, then B, then D. And it all has to do with them having this tied initial investment here. So let's go ahead and start with A. Upgrade from A to C, and so we'll check that, and we'll go A to C, negative infinity. Very, very, very bad idea, so we're not going to do it. So C gets knocked out, we stick with A, and then we see if we should upgrade from A to B. And we check this A to B increment, and we go, oh, it's a good idea, 84.58%, which is bigger than 20, so we throw A away, upgrade to B, now check the B to D increment. Now if you check the B to D increment right there, it's only 18.56%. Oh no, we're supposed to, stick with B and not upgrade to D. So you see where the problem occurs. And this is like very, very, very common in trying to use this exclusive choice internal rate of return criteria. You end up with your incremental internal rates of return with like multiple roots, which is a really bad idea. So let's go ahead and check the answer key page just to double check what was going on with the annual worth and some of the other calculations. Here's the answer key page, and yes, it was true that the internal rate of return was 33.98%. Sorry, 98%. I think I said 68%. And what's nice is that when you calculate all these annual worths right here, done automatically, D ends up being the largest one, which is what you should have chosen. So there you go. You have the answer to essential question number 3. Essential question 3, and I believe this is number 5 in the fall of 2011.